What's up guys, Jamie here, and today we're looking at hyperbolic functions. So the first piece to look at this that's important is how you can rewrite this equation of e to the power of x. And e to the x is equal to this function right here. E to the x plus e to the negative x over 2 plus e to the x minus e to the negative x over 2. So this first function you see here, this is the even function right here, and the function that we're adding to it is an odd function. This first even function is the hyperbolic cosine of x, which we call the cosh of x for short, and this odd one is the hyperbolic sine of x, which is sinh of x for short. And so the reason this was created is because when you take sinh of x and you add it to cosh of x, you get e to the x. And so now using these formulas for sinh x here and for cosh x here, we can get all the other trigonometric identities for these hyperbolic functions. So this tan one, which is pronounced tanch of x, according to the textbook, we can just do that by dividing sinh of x by cosh of x, which you get right here. Cotanch of x you get by dividing cosh of x by sinh of x, leaving you with this function right here. Sech of x you get by 1 over cosh of x, which ends up with just flipping this function right here. And sort of the same thing over here with cosech of x. You just flip sinh of x to end up with this function right here. So for the graphs of these functions now, so let's start with sinh of x. It's taken using the boundaries of y equals 1/2 e to the x and y equals negative 1/2 e to the negative x. And you get a function that slope begins to decrease more and more as it approaches 0 right here, but it's always positive, and then it begins to increase again up here when x is greater than 0. For cosh of x, it's divided by the boundaries of y equals 1/2 e to the x and y equals 1/2 e to the negative x. Basically just looks like your normal parabola. For tanch of x, it's created by the boundaries of y equals 1 and y equals negative 1, as you can see here. For cotanch of x, it's a similar thing, except it's outside of those boundaries. For sech of x, you have this function inside the boundaries of y equals 0 and y equals 1. And for cosech of x, you have this function right here inside of the first quadrant and the third quadrant.